All right, guys, we're going to test out this other type of software as far as screen recording goes using Screencastify. We'll see if I like it. So for this one here, we got our beginning of proofs. We love proofs. Everybody loves it. All right. So we're going to do a couple two-column proofs, just get our feet wet here, just kind of getting used to it, some of the language and stuff and the formatting. All right. So I think we actually already added in congruent, but if you haven't done so already, congruent is a biggie. All right, if two segments or angles are congruent, then they have the same measure. All right, so this applies to angles, applies to segments. It actually then will apply to triangles, polygons, all sorts of awesome stuff as we continue on through this school year. All right. Now, converse. What does converse mean? All that means is that we're just flipping it. So if we were to write that out, if two segments or angles have the same measure, then they are congruent. Yes, and I do remember we went over congruent because I talked about the congruent sign. I never write the word out congruent. There's too many letters. That's a waste of time, in my opinion. Time is money. That ain't funny. I'm going to jot down that congruent symbol instead, okay? So the converse is just flipping it, all right? The converse does not always hold true. In definitions, it does, but in other statements, it does not always hold true, okay? If it's raining outside, then it's cloudy. Pretty much always true, except for like rainbow times, right? But there's going to be a cloud somewhere, right? But if it's cloudy outside, then it's raining, does not necessarily hold true. It can be cloudy and not raining, right? There's got to be some clouds if it's going to rain, but if there's clouds, that doesn't necessarily mean there's rain. All right, so converse does not always hold true, but for definitions, it does, and we'll get into that a bit more later on. Okay, so our first example, we're going to start with just numbers here to keep things a little bit easier. So our given information is that AB is equal to 4 and CD is equal to 4. Remember, when there's no segment marking up top, right? If I don't have this, then we're talking about a segment length, the distance between A and B, the distance between those 2 points. So for our given, we're just going to write out what was in the given. And our reason is that this is given. This is one of our favorite steps because we can always get it right. Just have to copy it down. Woo! Okay. Now our second step, well, to say that they are congruent, that's just saying, hey, if they have the same, we're using the converse here. If two segments or angles have the same measure, then they are congruent. Do these have the same measure? They certainly do. So AB is congruent to CD. I like it. And our reason is definition. What's the start of the next period? Definition congruent. You could write out if two segments have the same measure, then they are congruent. We're going to use definition congruent so often we're going to know it means that we're just going to write out def congruent. Okay, save a little bit of time. We get to writing quite a bit in some of these proofs. Okay, a couple theorems. Fantastic. If two angles are right angles, then they are congruent. Okay, that makes sense, right? If they're right angles, they're 90 degrees. They're going to be the same measure. They are congruent. It's almost like a little shortcut. You don't have to say that they're 90 and then use definition congruent. We can just say if they're right angles, they are congruent. And we have another one, same kind of a deal, but this time with straight angles instead of right angles, then they are congruent. Now, here's a good one. Could we reverse these? Could we use the converse? If two angles are congruent, then they are right angles. That doesn't necessarily hold true. So for theorems, the converse may or may not hold true. It just depends on the situation. Okay. But two useful theorems to jot down. We're gonna use them here in just a sec. All righty. So for this one, it says if two angles are straight angles, then they are congruent, and we want to prove this. So one thing that we do in this class is before we can really use theorems, they actually have to be proven. That you have to be able to prove those theorems to be true. So we can't use the theorem to prove it. We're going to just go the route of like using our definition of what a straight angle is and some other definitions that we know. So first thing, our given is that, let's say I'm going to draw a diagram actually so we can list it out. So let's say we have A, B, C, and this can go on forever. And then let's say we have D, E, and F. Okay. So our given is that angle ABC and angle DEF are straight angles. And I'm going to be super cool and hip. Straight angles. Oh, yeah. And then we want to prove that they are congruent. So our proof statement is angle ABC is congruent to angle DEF. All right. So we've got everything that we need. Cool. All right. Let's see here. I'm going to switch colors. I'm going to go with this lovely color here. So our first part is our given, right? And that would be that angle ABC and angle DEF are straight angles. And then we have our given. Cool. All right, well, what do we know about straight angles? Again, I can't use this new theorem without proving it. So what do we know about straight angles? We do know that they're 180 degrees, right? Okay, so angle ABC, that was terrible handwriting, is 180 degrees. Angle DEF is 180 degrees. I like it. And our reason for that is definition of a straight angle. Or we could say straight angles measure 180 degrees, something like that, okay? And then lastly, well, they're the same measure, aren't they? That's what we've got, 180 degrees and 180 degrees. So by definition of congruent, they are congruent. So I can say that angle ABC is congruent to angle DEF, and that'd be definition congruent. All right. But now that we've proven this, right, we've proved this theorem to be true, we can just go shortcut style. If I gave you that they were straight angles and asked you to prove that they were congruent, you could do this in 2 steps now instead of 3. And you're going to see that a lot as we start introducing new theorems and definitions. Our proofs are going to get longer and then shorter. It's going to be like an accordion throughout the year, okay? Cool. Next one, we have RST is equal to 50 degrees. Should have little degrees. This was all done, this PowerPoint was done before math type was a thing, which is why these look like the greater than symbols. It's angle is what we really are using them, okay? All righty. Then it says angle X is a right angle. I'm going to notate that, and the way we notate that is with a little box there, all right? And then it says TSV is 40 degrees. Cool. Well, we want to prove that RSV, which is this angle right here, is congruent to angle X. I know that RST is 50, so I'll jot that in here. And I know that TSV is 40, so I'll jot that over here. Well, what do we know about 40 and 50? I believe that would add up to 90 degrees. Is at 90 degrees is a right angle, so it looks like we can actually match these two up. So we have a general game plan. I like to have a game plan before I start writing these proofs out. So let's do that. So for our first part, it's going to be our given. To save on writing, I'm just going to draw an arrow down. All right. Next, let's add those two together. Now, the way we do this in proofs, we don't say 40 plus 50 adds to 90. What we're going to say is that angle RSV equals 90 degrees, and then by addition property, add prop. Okay, so what that's saying there is that we added 2 angles together to get 90 degrees. All right, that's built in. If you wanted to add in there that you added 40 and 50, that's cool. I need to see this part right here. I have to see angle RSV is 90 degrees. Okay, that is so important because what we're using now is that it is 90 degrees. You'll see in just a sec. So I've got 90 degrees for RSV. I've got a right angle for X. I have to get those to be the same thing. So I've got 2 options here. I'm going to go the route of saying that angle X equals 90 degrees. And my reason would be definition of a right angle. because a right angle measures 90 degrees, right? You could write that as your reason. Right angle measures 90 degrees. Definition of a right angle. All right angles are 90 degrees. 90 degrees in a right angle. Something like that is fine. And now my last part, angle RSV is congruent to angle X. And since they have the same measure, 90 and 90, I know that they are congruent. By definition, congruent. Cool? So that the reason why it's so important to say RSV is equal to 90 degrees is because I'm using that RSV as 90 and I'm using that X as 90 to say they are congruent because the definition of congruent says that they have equal measure. There is an alternative way of going about this, and I'm going to do this in a different color off to the side. In step 3, I could have gone in the route of saying that angle RSV is a right angle, and my reason would be definition of a right angle still. But now, since RSV is a right angle and angle X is a right angle, I could say that they are congruent. But my reason would be all right angles are congruent. Since I've established that they're both right angles in this scenario, I need to say that all right angles are congruent. In this one, in the purplish pink, whatever, what do you want to call it, magenta, I established that they're both 90 degrees. So I'm referencing their degree measures. So I say that they're congruent. Okay. So there are some little subtleties we're going to have to get used to here because the details are important. All righty. I think we'll call it a day on that one. Couple proofs done. I like it. We can start on your homework. Cool. America, freedom, rock and roll. Oh, America, wait. America, freedom, rock and roll, Costco. Riverdog Jenny on the ground. Make sure you follow. You guys have a wonderful day now.